In this example, we have rectangular equations and we want to convert these to polar form. So we're going to go back and use the definitions that we used when we converted coordinates. First of all, we have x squared plus y squared equals 16. And we know that x squared plus y squared is r squared. So r squared equals 16, which means that r is 4. And this would be our polar equation for that rectangular equation. In example B, we have y equals 9. Well, y is equal to r times the sine of theta, so that would equal 9. And so if we solve for r, we would have r equals 9 divided by the sine of theta, which is the same thing as 9 times the cosecant of theta. So our equation is r equals 9 cosecant theta in polar form. In example C, we have x times y equals 16. Well, x is equal to r times the cosine of theta. Y is equal to r times the sine of theta. So that would equal 16. If we multiply, r times r is r squared. So we have r squared cosine of theta, sine of theta equals 16. So r squared is equal to 16 divided by the cosine of theta times the sine of theta. And a lot of times, so that you won't have a fraction, 1 over cosine is the same thing as secant, 1 over sine is the same thing as cosecant. So we could rewrite this to say r squared equals 16 secant of theta cosecant of theta. And there is our equation in polar form.